Okay, today we'll be going over coins on chessboard, an easy probability question possibly seen in quantitative interviews. So the question statement is as follows. A chessboard consists of 2-inch by 2-inch squares. We toss a coin diameter of 1 inch that lands somewhere on the board randomly. What is the probability that the coin is completely within one of the 2-inch by 2-inch squares and not on more than one square? So let's take a look. So we can model this as the chessboard. We're trying to see the probability that a coin lands specifically inside of a square as seen. So we can scale down the problem from the 64 square example to a 1 square example because the probability that a coin lands in one square would be the same as the probability that the coin lands in one square on the whole chessboard. So if we take a look at this coin right here, it can land anywhere inside of this square and count as an active, as a success. But if it lands anywhere outside the square, like here for example, it will be in multiple squares and will count as a failure. So let's take a look at what probability that this coin lands exactly inside one of the squares. So here I've made a drawing of what the furthest out a coin can be and still land inside the square. As you can see, they all line up with the edges. But one thing to note is that the coin must lie within this square here. Anywhere outside of that, and the coin will not lie within the square. So now here's exactly what that looks like. If the coin lands anywhere inside of this yellow circle, the center of the coin, then it will land within only that square. If it lands anywhere outside, then it will land in multiple squares, which is a failure. So now let's calculate how big that center piece is, and then we can divide that by the total area to find the probability that the coin lands within exactly one square. So as you can see here, the big square is 2 by 2, and the coin itself has a diameter of 1 inch. Thus, this little segment right here, as you can see from the previous picture, this segment right here is exactly 1/2, and thus this square has exact side length 1 by 1. So the probability that it lands completely inside the square is the same as the probability that the center point lies within the yellow square, which is also the area of the yellow square over the area of the big square is 1 by 1 divided by 2 by 2, which gives you a final answer of 1/4. So our final solution is 1/4. Thank you.